Hi everyone, I'm Marzan Oyshi, and today I will be presenting TmoTA, a simple, highly responsive tool for multiple object tracking annotation. My co-authors are Sebastian Vogt and Stefan Gumhold, and we are from the Chair of Computer Graphics and Visualization of TU Dresden. Supervised learning is a predominant machine learning approach in many application domains, and it requires labeled data to train a model to make predictions or decisions. However, the success of supervised learning depends on the quality of training data, which must be labeled accurately. The process of labeling data can be time-consuming and expensive, especially when large amounts of data are involved. Our goal is to reduce annotation time by designing a tool that is fast and easy to set up, easy to learn and to use, reduce number of actions, and has high responsiveness. Our new tool is designed with a simple and intuitive user interface that is easy to navigate even for novice users. Additionally, our tool is open source, which means that it is freely available for use by anyone and can be customized to meet specific needs. Our tool is portable, and it makes it easy to collaborate with others to work on annotation tasks in different locations. Our tool is responsive, which means that it is quick to respond to user input, resulting in a more efficient and productive annotation process. While designing, we focused on the interaction method that ensures fast visualization. We provide a comparison study where we compare our tool with manual annotation tools like CVAT and Label Studio, and also with two semi-automated tools on the context of annotation time and quality. As per the study, our tool can reduce annotation time per object from 20 to 40% compared to the manual annotation tools. Our background study focused on the direction of annotation method that characterizes annotation medium and the type of annotation labels. Here are some examples of the annotation tools. Annotation medium can include different data types, for example, image, audio, and video. Type of annotation depends on the data type and can be bounding box, polygon, or text classification. Combining the annotation medium and the annotation type, the degree of automation can be manual, semi-automated, or automated. Incorporating gamification can increase the fun factor to the tedious annotation task, but it slows the entire annotation process. Analyzing the related works, we can say that you can have a tool focused on a single data type and approach for faster annotation, or multiple or gamified tool for broader annotation, but then you will have to compromise with speed. In our case, we want to minimize labeling time. To save annotation time, our method focuses on specific annotation method, which is videos, and annotation time, which is bounding box. We decided to continue with manual annotation process using linear interpolation to reduce complex calculation that compromises the responsiveness. We offer a portable tool that reduces the installation time. As part of visualization, we offer features like view centering that allows to adjust the view of the video view to the currently selected object, and ping pong playback that toggles playback direction at the beginning and end of the video such that it plays back and forth all the time. Videos with large number of pedestrian bounding rectangles can overlap and occlude each other a lot. This makes selection of the current object difficult. We offer occlusion handling to resolve this issue by supporting cycling through the set of all bounding rectangles. As part of interaction, we focus on appearance-based objects where objects are divided into appearances to deal with occlusion and reappearances. We use anchorless bounding box interaction to have a broader peak area with less traveling range. Small changes can be done with single click. It is possible to adjust the bounding boxes using 3 different ways. User can drag and drop the edge or the corner, drag and drop the nearest edge or corner, or simply by drag and drop the whole box. We implemented our program using open source SIGCHI framework. We store all the video frames into the main memory and only transfer the current scene into 2D texture before each rendering process. The video view and the object view is rendered using OpenGL version 3. We use two custom-tailored shader programs to render current object with a quad and render bounding rectangle of all other objects. The current object is shown with an inverted rectangle that blends object color over the whole video frame except inside of the bounding rectangle. The reason to use inverted view for current object and during box editing is to better see the labeled object without diminishing contrast through coloring. As per evaluation, we conducted pre-case studies to support tool design and conducted a user study to validate our tool. We compared our labeling tool with two manual tools, CVAT and Label Studio. And we also compared with two semi-automated tools, Supervisely and Batik. 17 computer science students participated in user study. For the video, we used 4 videos with 10 objects each. The videos include static and dynamic scene. During the study, each participant had to label 2 videos out of 4 using 2 assigned labeling tools. It was randomly selected to avoid biasness. The entire study was guided by a single instructor and the labeling time per object were recorded using manually stopped timers by the participants. For all the tools, we calculated the average, standard deviation, the lowest observation and the highest observation per object labeling time and per object frame labeling time. Analyzing the user study results, we can say that TmoTA is 20 to 40% faster compared to the manual annotation tools, and semi-automated tools are 20 to 30% faster compared to ours over the first 20 annotated objects. But we do have advantage in the learning curve. We measured the learning curves as all the users needed to learn the tools using the available tutorials during the study. Here you can see the curves for manual tools. This gray curve is for Label Studio, blue one is for CVAT, and the orange one is for our labeling tool, which is TmoTA. Here you can see the learning curves for semi-automated tools. The green one is for Batik, and the yellow one is for Supervisely. Using the trend lines, you can see that semi-automated tools do not seem to improve over time, and our tool has the lowest learning curve, converging first with the semi-automated tools. We also calculated the system usability score to understand the usability of tools. The SAS score for CVAT is significantly higher. To evaluate the participants' accuracy, we calculated multiple object tracking accuracy and multiple object tracking precision. To assess the quality of annotation, we calculated high order tracking accuracy, also to ensure comparability. From the graphs, we can see that CVAT, TmoTA, and Supervisely has the higher accuracy and Batik has the worst results. This means that this tool might lead users to be not as precise as for other tools. Although we have a fast annotation, at the end, SAS score for CVAT is still better than us, and as like other labeling tools, our tool is limited to video that fits into the main memory. In future, we plan to improve the system usability. We want to conduct an extensive user study with more training. Even though semi-automated tools are faster than TmoTA, we see a high potential that our ideas can speed up semi-automatic tools even further, and we want to investigate this in future. I can conclude by saying that we introduced a labeling tool that is portable, open source, highly responsive, easy to use, and fast. And our features like ping-pong playback, view centering, occlusion handling, and anchorless bounding box manipulation support us to reduce the annotation time for an object frame by 20 to 40% compared to the manual annotation tools. Here are some references that we used. I would like to thank our funding body for supporting us and also thank the user study participants. Thank you for your attention, and I hope that our tool will prove to be a valuable asset for your work. Please read the paper to have more insights. Thank you.